Hey guys, Mr. Anderson here again with you for another edition of Geometry. Today we're in section 3.5 talking about proving lines parallel. Most of what we're going to talk about today is very similar to things that we've talked about, so this shouldn't be too long today. All right, so let's get started. First of all, our objectives. We're going to recognize angle pairs that occur with parallel lines, and then we want to prove that two lines are parallel. Okay, so remember before the situations that we looked at, we'd say, hey, if we have two lines that are parallel, if A and B were parallel, then we knew that when a line cuts across a transversal, we knew that certain angles were congruent to each other. So for an instance, in this case, angle 1 and angle 3 are corresponding angles, so that we knew that corresponding angles were congruent. All that's happening here today is we're saying, hey, we don't know that these are parallel, but if we know that angle 1 is congruent to angle 3, so if 1 is congruent to 3, then we know A and B have to be parallel. Or if 2 and 4 we know are congruent and they're corresponding angles, then we know that A and B have to be parallel. So the same thing for all of the different corresponding angles, okay? So it's just kind of looking at this from the opposite way that we've done it before. So this is called the converse of corresponding angles postulate, okay? As you can imagine, there's a few other ones as well, all the other ones that we were talking about, and here they're listed right here. And so you notice, first of all, alternate exterior angles, converse, just says if you have two alternate exterior angles that are congruent, then those two lines have to be parallel. So in this case, P and Q. There's the consecutive interior angles, converse, and that just says if you have two consecutive interior angles, if you're told that they add up to be 180, like right here, then we know that P has to be parallel to Q. All right, there's the alternate interior angles, which means if you know that, in this case, 6 is congruent to 8, those are alternate interior angles, then the alternate interior angles converse says that P has to be parallel to Q. And then, of course, we hadn't really talked much about this, but when you think about it, it kind of makes sense. The perpendicular transversal converse, it just says if you have two lines and they're both perpendicular to the same line, like P is perpendicular to R and Q is perpendicular to R, well, then they have to be parallel. And you think, well, that makes sense because the way it's drawn here, hey, those would be corresponding angles. They're both 90. Oh, but wouldn't all of these be 90? So, for example, this angle here and this angle like right here, those are alternate interior. If they're both 90, they'd have to be parallel. Also alternate exterior angles like this one out here and this one down here. Also, if both of these are 90 in here, 90 plus 90 is 180. So you can see that this perpendicular transversal converse kind of applies to all of them if you have 90 degrees there. Okay. Well, let's just look at and see what we can do with some of these. All right, so first example here, angle 1 is congruent to angle 5. So we want to determine which lines are parallel and then state the postulate. So let's look here. Here's 1. So here's angle 1 and here's angle 5. All right, so those are the angles. What is the relationship between those two angles? It might be a little harder because you've got extra lines and angles in here that we're not used to seeing. But look at it this way. Angle 1, it's made up partially of line P, but also partially of line L. And angle 5 is made up of P, but also N. And so you notice the two lines that made up both of these angles, L and N, those are the lines that are going to be parallel. So over here we could say L is parallel to N. This is the symbol for parallel, two lines straight up and down, so that would be line L is parallel to line N. Which one of the theorems or postulates was that? Well, what are these called? Just kind of block out the M in your mind since that doesn't apply. Just look at the other two. 1 and 5, it would be what? The same corner house, the next block over, actually 2 blocks over, so that would be corresponding. So that would be the corresponding angle. And I think it was said I think they said the converse of corresponding angles, but if you just said corresponding angles converse, That would be fine. Okay, next one. This time 2 is congruent to 3. All right, so here's 2 and here's 3. So again, see which lines those are attached to. Angle 2 is made up partially of L and P, and 3 is made up of M and P. So the two lines that they're attached to here are what? L and M. So L and M, L is parallel to M. And which one of those theorems or postulates says that? Well, what are these angles? They're alternate interior angles, and so this would be the alternate interior. I'm going to abbreviate that. That's angles converse. Okay, so that's the alternate interior angles. It's like an angle sign with an S in it. Okay, so the alternate interior angles converse. All right, thirdly, how about this one? Angle 4 and angle 5. Here they are right here. They add together to be 180. Well, if you look at that, say, hey, if these add together to be 180, well, what lines must be parallel then? M and N. And so here we would say M is parallel to N. And why is that? What are those angles called? They're called consecutive interior angles. And that's the consecutive interior angles converse. Okay, hopefully you're getting this pretty easily. Let's see, how about this one? 1 and 6, this time it's 1 and 6. Okay, well, what lines are those both attached to? Well, this 1 is attached to line L, and 6 is attached to N, and so this would be L and N. And what are those angles? What? Alternate exterior. So alternate exterior angles converse. Yeah, when we talk about, I didn't mention this earlier, but when we talk about converse, remember, I'm not talking about the shoe here at Converse, not talking about Chuck Taylor's. I'm talking about, converse is kind of like the opposite, or it's kind of looking at it from a different angle. So that's all we're talking about there. All right, a couple more examples and we'll be done here. This example now is going to be very, very similar to what we had done before, okay? The only difference is I said find the measure of this angle ZYN, so that PQ is parallel to MN. But we're going to kind of set it up the same way. We're going to say, well, look at what we've got here. We've got 11x minus 25, 7x plus 35. Is there some relationship between these two? Okay, well, they're alternate exterior angles, right? So remember, this is interior, is between the two lines, and so these are both exterior, and they're on the opposite side of the transversal. So we know that alternate exterior angles are congruent to each other. So 11x minus 25 will equal 7x plus 35. And then we solve it, so minus 7x plus 25. And so that's going to give me 4x equals 60. Divide by 4. X is 15. Yay! Oh, but wait. What were they asking for? ZYN. Okay, so ZYN. What do I have to do to find ZYN? ZYN is this angle right in here. Of course, I partially covered that up. But that's the 7x plus 35. So what do? Plug it in. Okay. So the measure of angle ZYN will just equal 7 times 15 plus 35. And so that'll be 105 plus 35, which equals 140. So the measure of angle ZYN equals 140. Just like we did before. So no big difference there. And last one, find x. So this time all we have to do is find x so that these two lines are parallel. And so if you look here, look at the two angles that we have. What's their relationship? They're alternate interior angles. And so what do we know about alternate interior angles? They're congruent. So we would say 9x minus 21 equals 7x minus 3 minus 7x plus 21. So that gives me 2x equals 18 divided by 2 and x equals 9. And if you wanted to check your work here, all you'd have to do is plug x back in to both of these, and you should find that you get the same thing both ways. It looks like 9 times 7, 63 minus 3, it looks like is 60. And then 9 times 9, 81 minus 21 is also 60. So that looks good. We got it. Okay, that's it. Like I said, real short one today. Appreciate you being here. And we'll see you next time. Next time, we'll be back in chapter 4. All right, see you then.